Hi students, today we will discuss about epsilon delta definition of a limit. See, let f of x be a function defined on some neighborhood of a. So clearly may be deleted neighborhood or neighborhood. So if it is deleted neighborhood, so f of a is not defined. Then the real number L is said to be a limit of f of x as x value approaches to a if for every epsilon greater than 0. So what is epsilon? Very small quantity. There exists a delta greater than 0. So both are small quantities, very small quantities. So clearly such that 0 less than mod x minus a less than delta, then modulus of f of x minus l less than epsilon. See what it means. So the difference between x and a is less than delta. Already delta is a very smallest value, and the difference between these two is less than delta, which means that x is very closer to a. And then so already epsilon is a very small value, and the difference between f of x and l is less than epsilon, which means that f of x is very closer to l, then only it is less than epsilon. Clearly what it means, so x minus a is always lies in between minus delta and plus delta, and then x is what lies in between a minus delta x less than a plus delta. So x value is always from the left side and from the right side, which means that x value approaches to a from the left side, which means a minus delta, and from this x value approaches to a from the right side, which means a plus delta. Clearly which means that what it means, x value approaches to both the left and right sides, which means x value approaches to a, that means very nearer to a. Why? Because the difference between these two is less than delta. Clearly the difference between these two is less than delta means x is very closer to a. Now come to mod of f of x minus l less than epsilon, which means that this f of x minus l is lies in between minus epsilon to plus epsilon, and f of x is what, l minus epsilon less than f of x less than l plus f of x, l plus epsilon. See, which means that as x value approaches to a from the left side, f of x approaches to l from the left side, and x value approaches to a from the right side, f of x approaches to l from the right side, which means that clearly what we get, f of x approaches to l. So as x value approaches to a from the both sides, f of x approaches to l from the both sides, which means that x is very closer to a, then f of x is very closer to l. What it means, the limiting position of f of x is what, limiting position of f of x as x value approaches to a is clearly is equal to l. Why? Because these two are very close as x value approaches to a. Now coming to the graphical approach, for suppose okay, let's consider the graph. Now it is l minus epsilon, l and l plus epsilon. So here it is f of x, the function. So these are the possibilities. So as x value approaches to a, clearly, so see this, as x value approaches to a from the left side, so which means that, so clearly the function approaches to L from the left side, so which is L minus epsilon. Here a left side means a minus delta. Clearly a plus delta, when x value approaches to a from the right side, which means from the right side, which is a plus delta, then clearly the function approaches to L plus epsilon. So which means that as x is very closer to a, then so clearly if it is x, then it is said to be f of x. So as x is very closer to a, then x is very closer to a, then f of x is very closer to L. So which means that what is the limiting position as x is very closer to a, then it is said to be L. So clearly limiting position of f of x as x value approaches to a is equal to what? L. So this is the very beautiful epsilon delta definition of a limit. So thank you students. So bye.